All right, example 4. Another one where we're asked to factor, and this is a trinomial. You got a cosecant squared x minus a cotangent x minus 3. Problem is, they're not the same thing. This is cosecants. It's cosecant squared and this cotangent, so they don't match up. So you can't go to factoring it. The last example I did, I had this, and I factored this right here. I had 4 tangent squared theta plus tangent theta minus 3. Well, they were both tangents, so you could factor it. If these don't match up, well, you can't factor it. There's something else, though, that you can do, and it has to do with your identities sheet. So what I'm going to go to is the most important one, or the important ones, as I say. They're just most important because they're used the most. The Pythagorean identities. And I'm actually not going to look at the one I've got circled here. There's 3 Pythagorean identities. This one's got sine squared and cosine squared. This one's got tangent squared and secant squared. And this one's got cotangent squared and cosecant squared in it. Now, if you remember how these work, if I have a cosecant squared at any point, at anything I'm doing in this class, I'm allowed to swap it out with this if it benefits me. And in this case, it will. If you think about it, I'm looking at this, so I can take the cosecant squared and I can swap it out. And according to my sheet, when I replace it, I have to replace it with both this 1 plus cotangent squared u, or cotangent squared x. So that's what I'm going to do. So then everything will be cotangent. So instead of this, I'll have 1 plus cotangent squared x minus cotangent x normal minus 3. And our trinomial now became 4 pieces, but this piece and this piece are just numbers, so you can really just mesh them together. So these two can just be put together, and you'll have cotangent squared x minus cotangent x minus 2. Cotangent squared x minus cotangent x minus 2. And now we can factor the trinomial. A couple good things about it is, one, it doesn't have a coefficient here. And yeah, no, that's it. It doesn't have a coefficient here. That's the good thing about it. I'm going to make a side note, though. I don't like to think about trig when I'm factoring. So what I'm going to do is I'm going to pretend I'm going to put the think here, little think box. Instead of cotangent squared, let's just think x squared. Let's just put minus x and then minus 2. And think about factoring that. I guess the good thing is when it doesn't have a coefficient here, it's easier to do. When I factored something a little while ago, I factored this a little while ago, and I had to do the Berry method because of that number there. Without that number there, factoring just means let's drop a couple parentheses. That x squared came from x and x. And then the numbers that go here and here, they have to multiply to negative 2. Well, the only way, I always do this chart, the only way that you can get a 2 is a 2 and a 1. And so that's definitely the numbers, so put your 2 and a 1 in there. And then if you want them to add or subtract to negative 1, you'll want to go negative 2 plus 1. And that's it. Of course, how does that apply to ours? Just remember, if we pretended the cotangent squared was an x, and we pretended cotangent was just an x, so when you're done, this is the answer, just where the x's are. That's just where cotangents go. Just normal cotangent. Cotangent x minus 2, cotangent x plus 1. But you have to be able to factor to be able to do this. Just make it an algebra 2 type of problem, and then factor it, and then change your x's into cotangent. And that's how we factor with our trig functions.